For number 6, we have a completely different setup than we did for numbers 1 through 5. It's talking about a rectangular piece of cardboard. So I want to draw a picture of this and try to wrap my mind around what's going on here. It says we need to cut out equal squares from the corners. It says let x represent the length of those sides, so that's what I've drawn. And then it says it's 8 inches by 14 inches. So I'll make the long side 14, the short side 8. And then it asks for the restrictions on x. So if you think about it, the smallest cuts that you can possibly make would be 0. But if you make any tiny cut larger than 0, then it will give you a box. Your box would be tiny, but it would at least give you a box. So the lowest x could be is 0. It can't be equal to 0, but anything bigger. And then the highest x can be is 4, because 4 is half of that small side. If you actually cut out 4 inches, then you'll have no box, because that side of 8 will be gone because you've cut out 4 inches from the top and 4 inches from the bottom. Then in part B, I'm drawing the picture for after you have made your cuts and you fold this thing up. Since x was the length of the side of each square that you cut out, that's going to be the height of the box. Top of the box is open. And then for the base and the side, you take your original two sides, 8 and 14, and you're subtracting 2x from each of those. So now we can just go back and write out the volume as length times width times height. And that gives us the volume in terms of x. If you multiply that out, the highest power of x will be 3, because you have 3 different terms that you're multiplying, and each term has highest power of x being 1. So that will be a cubic equation. That means this is a cubic model for this graph. In part C, if you want to find the maximum, you need a calculator or a computer. You could just set your equation that you found in part B. You could just type it in and type in find a maximum or maximize. I used an online program called Wolfram Alpha that's free to do this. On your exam, I won't ask you to do this, but it's something nice that you can figure out how to do for your homework. To find the actual maximum volume, you'll use a computer as well. Again, I used Wolfram Alpha. And then for part E, to find when the volume will be greater than 48 inches, you just take your equation that you got from part B and set the volume equal to 48. And when you do that, the computer will solve it for you. You just type in the equation and hit enter, and it will solve it. If you're using a calculator, you can type in y1 equals the part of the volume equation that we have on the right. So the 14 minus 2x times 8 minus 2x times x. Do y1 equals that. And then y2 equals 48. And it will graph the volume function, which is a cubic model, so it goes up and down and back up. And then the v equals 48 will be a straight line. And you'll just figure out what x values make those two curves intersect. So where does the straight line intersect the curving line? I want to talk a little bit about graphing this thing. We know the highest power of x is 3, so we know it's going to be a cubic model. And we can see some places where the volume would be equal to 0. From our equation in part B, it's already in factored form. So if you set each piece of that equal to 0, you'll find where the volume would be equal to 0. So for example, at x equals 0, the volume is 0. at x equals 4, the volume is 0. Because if you plug in x equals 4, in that middle piece, you'll get 8 minus 8 is 0. And then also when x is 7, you would get v equals 0. So we know the x-intercepts if we wanted to graph this thing. And also if you multiply it out, you would see that the coefficient of x cubed is positive, because it's going to come from the negative 2x times negative 2x times x. So that's going to give you a positive 4x cubed. So that tells us that this thing will go down as x goes out to negative infinity, and it will go up as x goes out to positive infinity. So we can get a pretty decent graph of this just from knowing where the x-intercepts are and that it's a cubic equation.